Well, welcome again to one of the Red Stack webinar series. My name is Guy Wallace and I'm going to be taking you through today some of the Autodesk Simulation CFD capabilities. We're going to be using the Simulation CFD product out of the Simulation Flex 360 product. It's a locally installed solution that allows you to solve both locally and in the cloud. You'll look at that a little bit toward the end of today's presentation. The study that we're going to do is going to be on human comfort ventilation. We have some goals that we need to meet today as part of the agenda. So the first thing is you can see a model there. It's actually a museum exhibit hall. We're going to be looking at the ventilation system where we're going to be understanding the different modes of summer and winter. We have to assign some materials, set up some of the boundary conditions, and then evaluate the flow and temperature distributions for the summer and winter days. So what we're trying to achieve is to see whether the occupant thermal comfort level is within the acceptable bounds. Obviously we want the occupant to hang around and to be comfortable while he's visiting the museum. So the reasons why the occupant comfort levels, we need to understand that, and we also need to determine if we need to modify the ventilation strategy. Toward the end of today, I'd like to ask that if you do have any questions, you can see my email address there. Just pop me an email through toward the end of the session or after the event. Take some notes as we go through, and I'd be happy to answer any emails that you have and questions regarding the study that you see today. So thanks for coming along, welcome on board, and let's get into it. Okay, so here we are in the Autodesk Simulation CFD 360 product, and so what I'm going to do, I'm just going to start off by opening up my file, and we're going to be using the Exhibit Hall Master Tutorial. As we open it up, what you can see there is a hall. It's just a 3D model. I'll try and rotate this slowly. This could have been brought in from products like Revit or Inventor. And what we're going to do, the objective is to evaluate the effectiveness of the ventilation system. We're going to be using some imperial settings. As I said, I am using a tutorial, so we're going to be using Fahrenheit. So across the back of the object here we have an inlet. This is basically the inlet into the room, and down below here you can see an outlet. I can hold some keys here and I can just hide some of the volumes here so you can see inside. So what you can see is our inlets there for air conditioning and our little human guy sitting there, and this is going to be the focus of the presentation today. Once we've finished, we're going to assess the human occupant to determine whether he's going to stay in the museum a little bit longer or rather than escaping to sort of more comfortable surroundings. We're going to look at the temperature and flow distribution throughout the zone, and the predicted mean vote, which is PMV, which is a measure of thermal comfort. So we'll use the CFD to create the study. We'll set up the two different ventilation strategies and we'll compare the results. It should take us around about within the hour, probably 45 minutes to an hour. There's no mock-ups here, no wind tunnels. It's not very complicated at all. It's just Autodesk Simulation CFD. So as I said, the exhibit hall itself consists of a roof. This is actually a wooden roof. The walls are also wooden as well. As I hide the wall here, we have a volume. We actually don't model the volume as such, but this is going to be the air volume. And again, holding down a couple of keys here, we can see our human occupant. The floor is actually made out of brick, and the air or the ventilation enters through a high wall supply here across the back wall, and then, as I said before, it exits through the floor level that we can't see at the moment as I've got this turned off. So our exhibit hall is basically in part of a country that is subject to some pretty severe temperatures, ranging from, and I'll use imperial values, 100 degrees Fahrenheit in the winter, in the summer, and then the low dips to 25 degrees Fahrenheit in the winter. So we're going to create the summer and winter scenario. Just one last thing, as you see me go through and set up the study, the back wall here, this is actually going to be adjoined to an existing wall. So when we set up our bounding conditions, you'll notice that we don't assign any specific heat thermal capacities and things like that to the back wall. So let's get ahead and start creating some of the boundary conditions. Okay, so I just want to introduce you to a few of the navigation tools. First of all, across the top here we have a ribbon. Typically with Autodesk products we have a ribbon, so we can use different types of ribbons. And I've got some tools here where I just simply hold down the middle mouse wheel and pan. I can roll the wheel to zoom, and then I can press down the shift key and I can rotate. Another really nice feature is holding the control key, pressing down the mouse button, and I can hide some of the objects in the room. Very easily just rotate around here. Try and do this smoothly for you because I know you're looking online. And this little guy here, our human occupant, this is what we're going to be interested in today. Now, just with some of the viewing tools and zooming tools, you can actually go in here to your options into the CFD product, and we can set up the navigation to suit whatever product that you're used to. So if you're using Inventor or Revit, or if you do some other products, we can actually set up the navigation to suit either one of those tools. Another nice feature is obviously the familiar design tree. We're going to see where we can create all of the different bounding conditions and the material properties and so on for the study today. And then we can see some sort of outputs coming down the bottom here, give us some insight as to what is going on. Okay, so in this step what we're going to do is assign some materials. Let me just turn on the wall and the roof again. We're going to use a material called glass wool as an approximation for the insulated wall. So what we can do is we can just simply select the wall and roof just by clicking the left mouse button here like so. You notice across the top here I've got the materials button selected. I simply go in and choose edit. So the material type, what we're looking for is a solid in this case. You'll notice that we have a lot of different types of materials here. So I'm just going to choose the glass wool material, and then just to verify that I've actually got that material assigned, I'll apply that. You'll notice that the glass wool here is shown down in the bottom left hand side. It's inherited that color, and you can see the material, and it's been assigned to those two objects. And obviously we've got a few more objects that we need to assign the materials to. So now that we've assigned the material to the wall and the roof, we're just going to go through and assign some more materials. Now as I move into the model here, you'll notice I have this large volume, and I spoke about it very briefly at the start of the presentation, that it's actually the internal air. We generally don't model or build air as part of the CAD or BIM model, but in this step it's a big empty space, and we're going to define that as air. So again, selecting the object, I can pick the material from the edit flyout window that pops up here. It's a fluid, and obviously you can see the different types again, and it is an air, and you can see again the different materials that we have available, and we'll just set that as variable as well. So obviously the variation in the air temperatures is need to be set. So as we apply that, you'll see again the objects change color, and the air has been assigned to the material of the solid. Let's just quickly go through now and do a few more of these guys here. So what we need to do is we need to come into these little bench tops. Now I can pick multiples here, so I'm going to pick two of these guys. You don't need to hold control or anything. Again, just go into materials. So I'm going to be a little bit more quicker as I go through. What I've done here is I've just jumped into the material database, and the database does allow you to modify or customize any of these materials that you can see. Obviously copy and create your own based on your own specific requirements regarding those materials. So this is a few here that come with the software. So in this case here it's a solid. The benches are actually made of wood, so I've got a wood material in here. See if I can just find that quickly. Scrolling down to wood, and we'll apply that. The floor here, I'm going to assign materials to the floor. This material here again is a solid. This is actually a brick, so we'll assign a brick there and apply that. And there's actually a material for our little guy sitting here. It's actually he's a solid little fellow, and he's a human. So we actually have a human material that we can assign to that body as well. So what you can see is you can see the different color variations now. You can see that we have all of our different materials assigned, and we have all our different colors and everything ready to go. So now we need to start setting up some boundary conditions. You can see that we can work down the design tree here, and we can start inputting the values that are required. Okay, so now we have our materials assigned. We need to set up some boundary conditions. It's quite easy, just simply move across to the next icon in the setup tasks. I'm just going to hold my control key here and turn on the outer walls and door. Sorry, the outer walls, and then I'm going to go in and select the surface to represent the inlet. So let me just pan this over here a little while. So the inlet surface is here. Simply go in and edit. And then I need to choose the type of properties on this condition here. So it's actually volume flow rate, but you can see we have a few other different settings available to us. So the volume flow rate, again, I'm working with the Autodesk simulation tutorial, so it's going to be an imperial but feet per minute. We'll just apply a value here, and you can see now, just as in materials before, it has a representation of a little bit of colouring on the face and what that colouring relates to. To add some temperature to this, because obviously it's an air conditioning inlet, I can simply go in and select the previous face, go in and edit again, and in this case here, although I'm not actually editing the existing, I'm applying some more conditions here. I can put in temperature. So we're just going to put in 64 degrees Fahrenheit and apply that. So we have those two conditions applied. Now the other thing what I'd like to do also is define the outlet as well, or the opening. This here is actually a pressure opening. So I'm just going to simply choose pressure. It's environmental pressure, so it's going to be set at 0 and apply that. And we've got some of those conditions defined. The next thing we need to do is to start looking at the rest of the model in a sense of the wall, the roof and the floor. So let's go ahead and do that. So for the outer conditions here, the exterior thermal conditions, there's quite a few different things we need to select in this case here. So I'm just going to go and start selecting all of the roof areas, walls. Remember that this back wall is actually a wall adjoining the interior of the building, so we're not going to assign any conditions to that one. We'll just keep going, selecting the roof, the front walls here as well, and just simply holding my shift key and rotating, I can grab all of the different areas that we need to choose here. So we need to edit this. Now the sort of condition that we're putting on here, it's actually the film coefficient, or the heat transfer coefficient. Obviously this is the thermodynamics or mechanics of heat flux, the thermodynamic driving force, the flow of heat through the wall. So we're sort of simulating that the outside temperature is quite warm, and we want to determine the film coefficient here. So it is a setting that we need to select. So in the type here, we can actually choose that condition. As I scroll down here, you can see film coefficient. We can then apply the value or the unit. Again, using the imperial settings here, we're going to go for feet per hour, I think is here. If I can just find that one here, which is this one here. And then obviously the temperature units being Fahrenheit, and then the film coefficient being the value of the coefficient for that condition. The reference temperature, as we defined, it's quite a hot day. It's 100 degrees Fahrenheit outside. So as I choose that one and apply it, you'll see that we've applied that condition to all of those different surfaces. And again, quite easy to do that, and obviously always captured in the design tree here, and we have those values and representation defined here also. Now the last condition we need to apply before we start setting up to run the analysis, and we are getting there, is the thermal properties of our little fella in there. So let's just hide these ones here, and you can see our little human. We need to actually go in and, he's obviously emitting some heat, so we need to take that into consideration as well. So let's select him, and we'll just edit the properties here. And the type of condition that we're going to use for our little guy, it's actually, again, just by going in and editing, it's just total heat generation. So we have a value here of total heat generation. This is a good one. You can use watts and things like that. So if you've got lighting in your room and you wanted to really get specific with your study, you can determine different lighting conditions in the room, and then obviously apply the heat generation as well. So as I set that one up, the last one is, there should be some stripes all over the little guy in question, and it shows him sitting there with all his stripes with the heat generated, obviously the human heat. So that part of the analysis is ready to go, pretty much ready to start looking at the mesh and setting up some of the mesh conditions. So to create the mesh sizing, it's actually pretty simple. This is probably the easiest step, because we can go into our mesh sizing here, and we could go in and pick a face, place in a mesh size on a face, and go around and do some mesh refinement and be very specific on how we create our mesh. But the easiest way is to use the auto size option. So I'm just going to choose the auto size option. Before I do that, let me just turn on the outside walls again. I need to use volume selection here, and we just choose the auto size. So what you can see around the model there, just make sure that we grab everything. Yep, and you can see a whole bunch of blue dots being represented around the model. The blue dots basically represent the nodes, or indicate where the nodes will appear. But we also would like to maybe preview the mesh before we run the simulation. So as I right click out here, and I can choose to go in and preview the mesh as well. So let's just select all. Let's just choose the preview option. So you can see there, it'll take a couple of minutes, or probably less than that, to generate. So obviously what you can see there is the mesh, the different mesh refinements. You can see on the floor there where the bench is sitting, there's a little bit more mesh refinement there as well. And obviously very coarse mesh over the large surface, the roof area of the model. So now that the mesh is complete, we can even go in and have a look at our little fellow in there. So let me just hide these two objects here. There's the wall, hide the air, and you can see the type of mesh refinement that goes on. Just by clicking a couple of buttons, we can see that that's a very automatic process. So I'll just zoom out again, just select all, and I'm just going to clear the mesh preview. So basically we're ready to run, but we've got a couple of other little things to do first. Okay, so as I said, in this step, what we're going to do is we'll enable the physical models of heat transfer that we'll use for these simulations. So as we move into solve, we're presented with a dialog box here, and I need to go in and change a few settings based on what I'm looking for and what I'm interested in. And obviously, as we've been talking about this particular study today, we're actually looking for thermal comfort. So I need to select the thermal comfort option, and then just choose OK. So that's going to give us thermal comfort. On the physics tab here, I also need to set up the the direction in regards to the flow. We're looking for heat transfer here. Obviously we need to define the direction of gravity, so we're just going to pop that value in there as well. And obviously radiation as well, because we have that radiant heat condition going on there. You can see a few other options around the screen. Now I'm not going to hit solve yet. I'm just going to close that, because what I'd like to do is I want to duplicate this analysis so that I can run both studies in the background. The nice thing about using CFD 360 is that I can actually run multiple analysis in parallel. So let's just give this a meaningful name. So I'm going to rename this study here to summer. Okay, so we've got the summer one ready to go, ready to run. At this point, what I'm going to do is very quickly just save the settings that I have, and then go through the process of duplicating that analysis to create the winter scenario. It's very easy to do. Just simply right click, and I'm just going to choose clone, give it a name. This one's going to be called winter. Choose OK. And so what I have now is I have a brand new analysis study called winter, complete duplication of the other one. All I need to do is to just change some of the settings. All the settings that we defined in the summer scenario have been assigned to the winter scenario, so all I need to do is change the supply temperature and the exterior reference temperature, being obviously the outside wall. So we saw the film coefficient before that we were looking at. This is the outside conditions. So what we need to do is we need to edit that. So what we're saying is outside now it is a lot colder, being the fact that it's winter. So instead of 100 degrees Fahrenheit, I'll move that out here so you can see what I'm doing here, we're going to choose the 25 degrees Fahrenheit. The other condition that we need to change also is the inlet. Obviously with the inlet here, as I choose to edit this one, we've got the flow rate, we've also got the temperature. So What I need to do is I need to change the temperature, because what we're doing is we are, you know, we want to push some heat into that room now. So previously we had 64, so we're going to heat it up a little and add 85. So very easily we can go in and make those changes. And once those changes are all done, we have the summer and winter scenarios. We're basically ready to run the analysis. So to run the analysis, we move into what's, we could just hit solve, that'll solve the winter scenario, but we're actually going to go into the solver manager here. I've got a couple of other studies that I did earlier just as I ran through the simulation, but you'll notice that we have some different priorities here. So what I'd like to do is I actually want to run the winter scenario first. So I'm simply going to change the priority there. Then I'm going to run my summer scenario, and these are the two scenarios that I'm going to run. I'm not actually going to run these other two at all. You'll notice also I have a drop down box here. What this allows me to do is to send the solution to the cloud, the solve to the cloud I should say, or run it on my local machine. Now the benefit of shooting it up to the cloud is that it's not sending any of your model, any of your IP, any of your design to the cloud. It's purely just sending the mathematics of the analysis, so all the node element values to the cloud to solve. It uses the Amazon servers. There's around about 400 or so servers there, multi-core objects, and it will solve very, very quickly. In fact, 32 times faster than if I did it on my local machine here. The good thing about that is that whilst it's solving, and I could have 10 different scenarios sending up to the cloud, I can still continue to use my computer, so I can continue to create other analysis type studies. It's not bogging down my local resource because all the resources is solving in the cloud. In fact, I don't even need a very high powered computer with excess amounts of memory by using the cloud option. So that's the Simulation Flex product. For today I'm actually going to solve these locally, just for ease sake, and I'm actually going to go and open up the other two studies that I did previously because I've already got these solves already ready to go. So let's have a look at what happens. I just simply choose submit, and then once they've been submitted, so they're now submitted, and now they're starting to run. And what you can see in the bottom left hand corner here, solving again on my local machine, is that it's queued to solve. It's going through the meshing process. We'll be able to see some plots going on as we get into it, and then after that we can analyze the results. So the analysis is still running. Here you can see the winter analysis is running, and the summer one is actually queued. The good thing about the technology, it allows me to actually work on some of the pre-existing studies that I've created. You can see it's my other summer one that I've already solved, and I managed to see a convergence plot out of that, similarly to the winter one. My machine's still actually whirring away in the background here. It's actually still solving the other two studies. And as I said before, if I took that to the cloud, then obviously there wouldn't be any workload on my machine. But my fan's actually running quite heavily as it solves, but it doesn't stop me from starting to interpret some of these results. So to view the results, I move on to the results tab. At the moment I'm just showing some global settings. As an example, if I was to choose temperature, you can see the whole object change to red, and this represents the 100 degrees Fahrenheit for the summer scenario. It doesn't make it very easy for me to see what's going on though, so what I'm going to do is change the display to outline, and what I'd like to see is my human shaded so that I can clearly depict what I'm chasing. So I do have a results area within the design tree here. Just going to right click here and choose shaded, so you can see my little guy sitting there in the room. What I'd like to do is just add a cross-sectional plane around my little person there, so I can actually see what sort of heat, whether or not he's comfortable. So I simply choose the planes option, and then I need to go and add a plane. So you can see that the icon bars change as I move in to start changing these settings, and you can see my little guy there. Obviously you can see that the nice cool air coming into the room represented by that plane. At the moment it's showing the outline of the plane. I'll just turn that off so that we don't see the outlines. And obviously what you can see is the film coefficient through the wall. There is some heat coming through the wall, obviously 100 degrees Fahrenheit outside, and it's coming into the wall. What I'd like to do is just rotate the model and just capture an image that I can use later for my summary images. So let's just rotate that around. You can see the plane there. I can actually very easily move that plane. Let me just do a little capture here. So what I can do is simply choose summary image just by clicking that button, and it goes and captures that image that I can use a bit later for the results tab. So the image is now saved to the design study. What it also allows me to do is in a few minutes we'll automatically apply the settings that make up this image to the winter scenario, and then we can compare the two temperature fields. Okay. Obviously, as I said, you can actually pass this plane through different areas. See the inlet there where the airflow is coming in. This can also be animated with trajectory plot as well, which we'll show you towards the end. So another nice feature is the ability to produce XY plots, and again we can use these in our results. So still using my plane here, I'm just going to go in and start creating an XY plot. Let's just look at it from the right hand view, zoom in a little, and simply go and add these points by picking. I'm just going to call this temp plot. Temp plot. So just going to add our points. Just going to pick a couple of points here, so quite freely. Let's choose our points here, and then choose plot. So you can see our temperature plot here. I can hide or show the points, and I can include this in my summary. So again, I can use this later in my results. So let's just close that, and we'll move on to the next step. So the next thing we're going to do is to look at the flow and temperature distribution by using what's called an ISO surface. Let me just remove this plane, and I'll go and select the ISO surface and then simply choose add. Now the ISO surface is a coloured representation that gives you a great insight to, it's basically a solid looking volume, gives you good insight into the relationship between the two quantities such as air, velocity and temperature. I'm not really interested in velocity as much as I am in the temperature, so I'm going to go in, I'm going to go edit this. Sorry, I'm looking for the velocity, not the temperature. So I'm going to change it to velocity magnitude. I want to have a look at the speed of the air through the room. And the other thing here is I can see my graph here. I actually want to modify this, change some of the units. Let's just work with feet per minute as a starting point. And then what I can do is I can go in and edit the graph, work with the ISO slider here, and actually make some changes to the values. So you can see here as I slide the object through, we're seeing some different values represented, or I can key in directly. So let's just say I put in 28 for example. So you can see there all the different colouring representing the ISO surface, and that shows the temperature everywhere in the model where the flow is moving at around about 28 or 35 feet, in fact in this case 28 feet per minute. So what I can also do is I can go into some of the vector settings, and I can display some of the velocity vectors as well, and I'll just turn these up a little bit so you can see what we're actually looking at. So you can actually see, I'll exaggerate this, so there are all the velocity vectors showing the direction of the air. Obviously you've got the velocity of the air as well, and you may need to adjust the vector length based on your requirements. I'll rotate them a little bit. It's an interesting view to show the flow behaviour in the hall. Let's just rotate that around and zoom in a little so you can see here. So it is very interesting, just showing the flow behaviour in the hall. The shape of the ISO surface is basically derived from all the different locations in the flow that have a velocity of 28 feet per minute. The vectors actually show the flow direction at these points, at these locations, and the colour shows the temperature. So notice how the cool air from the supply descends down into the seating area as the warm air, or as the air is warm near the walls, the direction changes and it starts rising towards the ceiling. So what I'd like to do is I want to save this as a summary image again for my results. So I'll just choose the summary image option. And then the image is now saved to the design study. And in a few minutes we'll apply the settings that make up this image to the winter scenario as well, and then compare the two temperature velocity fields. Because the summary image is actually now saved, we can delete the ISO surface just by choosing remove from the control panel there, and then I can start probing and interpreting some different results. So at the start of the presentation, we're actually focused on assessing the comfort with the predicted mean vote. To define a thermal comfort according to the standard, it is the condition of mind that expresses satisfaction within that thermal environment. So thermal comfort is an important consideration in the design and layout of spaces. If you're doing building design, if you're doing HVAC, air conditioning design, you need to understand what the comfort factors are in those areas occupied by people. So examples include offices, homes, libraries, stadiums, data centres, department stores and things like that. And it is a way to characterise specific conditions in which a known fraction of the occupants will find the environment thermally acceptable. So in this step we will actually use the predicted mean vote, the PMV, to assess the impact of the design on the hall and the ventilation strategy that we have. So the simulation CFD product actually, the PMV, calculates the PMV using several factors. Some of those factors are the local airflow velocity, the temperature, clothing, metabolic rate, humidity, radiant heat exchange and things like that. And this obviously assists us with determining how warm or cold a person feels within inside this space. So just want to make sure that little fella is displayed, and you can see him clearly in the room. So on the results on the design study bar here, so as I look here down the left hand side, I can see my fellow, and I can obviously choose him to be shaded, in which case is how he's being displayed right now. Let me just zoom in on my little guy here. So we're going to go for some global results. So we'll choose the global option this time. And similarly to what we did the last time, this time we've got this option here, and it allows me to choose the predicted mean vote. And you can see straight away the mean vote values of the person sitting in the room. So what do the values mean? So as a reference, it is an index that predicts the mean value of the votes of a large group of people on a 7-point thermal sensation scale. So it was actually, so for example, -3, that they would be very cold. Then it transitions into cool, slightly cool, 0 being your neutral value, 1 being slightly warm, 2 being warm, and 3 being hot. So we can see that the highest value that we have here is a 1. So that means the gentleman's actually slightly warm. In most of the or gentleman or lady, most of the area of our person here is actually within the mean vote range that is acceptable. So he doesn't really appear to be in too much discomfort. We'll have a look at that and compare it to the winter results in a moment. So what I'm going to do is actually going to save that image, and on the next step we'll compare those conditions to the winter results. So the next thing we're going to do is move to the decision center, and we're going to look at the summary images that we captured for the summer scenario, and we're going to apply those to the winter scenario, and so we can start comparing the two different design days. This is obviously the temperature cut plane that we did at the first step in the summer scenario. So we need to move into the design or the decision center here. So that's this icon here. We can start going in and comparing, and you can see here some of the images that we created. Well, you can't see them yet, but let me just go through and start renaming some of these things. So I'm just going to right click here and choose rename for our first image, and that was actually the temperature cut plane. Okay, so it makes a little bit more sense if we give these names, temperature cut plane, and just click on that one there, and from here, if I just simply go into the next area, we'll go and rename some of these other ones as well. So the second one I think that we did was the let's just rename that one there. That was the second image that we took actually. The second image here, this was the flow surface. So the flow ISO surf. Let's call that one too there. And then the last one that we did was the predicted mean vote. And you can see I've done these as well from the winter. So you've got a lot of different options that you can use, a lot of different information that you can capture. So I'm just going to pop those in there as well. So we're ready to update the images and then and the summary plot with the winter design scenario. So you can see I've got my plot data as well. So we just right click in the decision center here, just choose update all, so it goes and grabs those pre-saved images and goes and updates the thumbnails and whatnot. It's just going and grabbing those from the outside. So we should be able to see the temperature summary images from the summer scenario, and then we can start looking at putting these together to create some comparison, to create some differences and some comparisons. So you can see here I've got the different options here. They've got the flow plot here. It goes and captures all of this information, and I can see the two different cut planes. I can see the different ISO surfaces plots that I've created, and I can also see the zone temperature plots. So you can see I'm actually able to compare those zone temperature plots between the two different results, the different design studies, so the summer and the winter design studies that I created. So it's pretty handy to be able to capture and save that information. Let's just close these guys down. Now when I look at the different cut plots that I've created here, if I want to compare the two or drag the two guys together, then all I need to do is to grab the winter cut plot here and drag it into the summer one. And so then what I can do is I can actually just use this little slider here, and you can see in this case this is the winter, so the heat is coming in and moving, and obviously hot air rises, so moving up into the room, and this one here, the heat is coming down. So it's a very nice way to be able to compare the two results. And then you can obviously create an animation of these or play things. I don't have very many here, but you could imagine if you had a whole bunch of these different animations, different things that you've done, you could actually create a full cycle display, hit play here, and it'll go through and start cycling through the two different results. So we'll have a little bit more, obviously, again with the flow, the ISO surfaces, you can see the two there. So what we'll do is we'll go and grab the ISO surface here, and similarly with the plane, the temperature cut plane, we can compare the two different results in regards to where the airflow is and the velocity. And you can see in the winter scenario, obviously again, you can see the air going upwards, and again in the summer, the cold air going downwards. This information is quite easy to capture, as we saw in the previous steps. So that's pretty much it. When we start looking at some other information here, the last one that we looked at was the predicted mean vote. So we can actually show the variations again in summer and winter. So our little fellow here, as we've come through and gone through the analysis, looked at the different conditions, we've been able to determine that our fellow is reasonably comfortable. In fact, the goals of the exercise at the beginning, was obviously to evaluate the flow and the temperature distributions for those 2 days, which we were able to achieve very easily with the results that you can see here. We're also looking for the occupant thermal comfort levels within the acceptable bounds, which again is something that we've been able to understand. But obviously, if that wasn't the case, and we may have multiple people inside our room here, we'd be looking at redesigning or modifying the air conditioning system or the ventilation strategy if necessary. So it's a good time to obviously look back at what we've gone through. Being able to assign some of the settings and clone the summer scenario to winter was a good time saver. Using the solver manager to run both simulations, again we could send these to the cloud. We then jumped into the decision center, compared the temperature, flow and occupant thermal comfort levels. We had a bit of fun too. So based on the results, it's pretty clear that the summer ventilation strategy may not provide the optimum occupant experience, whilst the winter strategy seemed to be a little better. In the summer design day, the occupant's front appears fairly comfortable, but when we span around the back, we have a look in this particular example here, we can see some of the values changing as we move. So you can see those, starting to get a little bit chilly on the back there as we move down in the summer scenario. So just need to be conscious of that. But it's obviously a good experience for the occupants back. We plotted the results. We also created the ISO surface results so we could see both those actions. And this can lead to energy savings and reduced cost. A typical next step would be to fine-tune the ventilation strategy. We'd probably clone the summer scenario again, modify one or more of the conditions, run the simulation, and then continue to compare the results using the simulation center. Okay, so just to finish off with today, I'd just like to show you an animation of the flow trajectories as they come into the room. And this is one of the really good fundamental features of CFD, where we can actually analyze and understand the way or the circulation and airflow to see if we've got all of our vents and exhaust and everything sitting in the most optimized position. So this is the summer study again. Here you can see the cold air coming in. Basically we're looking at velocity, so the speed. It's obviously going down as it hits the floor. It slows down. There's a slightly brighter colour on the inlet as it's coming out, and this will keep going. There's around about 200 steps we're into now, but it'll go right up to around about 5,000 steps as it animates the flow in the room, and you can see it circulating, bouncing off the walls. You can just see in the far right hand corner now some of the flow starting to go towards the outlet. And the coloration change in the outlet there, as you can see, obviously there's some pressure, as obviously we've got more inlets than we have an outlet, and there's an increased pressure going on into the room. So it's a really good way to get an insight as to where the air flows are circulating mostly. You can clearly see that where our human's sitting, or you can't see him anymore because he's covered by the lines. But this can also be represented in a lot of different ways. So in the dialog box here I can choose different types of representations, whether it be points. I'll just increase the maximum amount of points here for you so you can see what all the different points look like. And by being able to change the representation here, so the typical sorts of settings that you have, spheres, let's just go into that one there and close that one, and we'll just continue there, and you'll be able to see lots of different ambulance driving past, sorry about that, and you can see lots of different representations here. Let me just try one more here. That one didn't come out overly too well. Let's just go with the ribbon lines. So there's some ribbons, and you can determine the ribbons and the sizes. We have things called comets, another different way of displaying the flow in the room. The cylinders was the one that I was using, so circular shaped flow, and simple representations using lines, showing it around the room. So that's it. That's the end of the presentation for today. I hope you enjoyed it. As I said before, if you do have any questions, please feel free to email me. My email address is up there on the screen. It's gwallace@redstack.com.au, or you can call one of our offices and obviously just ask for myself or our technical team, and we'd be more than happy to answer any questions. I hope you enjoyed the session. I hope you got to see how the CFD product works, how simple it is, and we look forward to seeing you the next time. So from me here, Guy Wallace, I'll see you the next time that we have a presentation online. Hopefully get you to come along. Thanks.